The Martian Colony Construction Robot, or MCCR for short, is our solution to the ECE 3091 Engineering Design Project for Semester 2, 2015. It is designed to conform to all the strict guidelines of the competition. Fully autonomous, it is capable of reading a construction plan, then identifying, retrieving, and stacking foam discs accordingly. It is designed to work independently, but can operate in a dynamic environment with 3 other robots. The project presented a complex problem. We aim to simplify the solution as much as possible in our design. The MCCR is a single unit and built on a sleek aluminium chassis. It is designed to be both lightweight and durable. The MCCR travels using a 2-wheel differential drive system. This involves 2 DC brush motors and a steel transfer ball at the back for stability. This provides good maneuverability and is also fairly simple to implement. To manipulate foam discs, the MCCR is equipped with a gripper and elevator system. The elevator system consists of a ladder chain driven directly by a stepper motor. The stepper motor provides sufficient torque such that no further external gear reductions are necessary, thus eliminating nearly all backlash. Using a stepper motor here allows for a high degree of accuracy and a high holding torque.
At this startup, our robot scans the construction plan using the camera that has been provided to us. We use blob detection along with four-connectivity analysis to identify the different colored magnetic pucks. We have adjusted the gain, the exposure, and the thresholds of the camera to optimally identify the 3 different colors, red, blue, and green, in the actual competition environment. The camera keeps taking images till it has successfully identified 4 pucks and performs a 180-degree turn to face the arena. The magnetometer is able to continuously provide the heading of the robot in degrees with reference to an initial value. This provides the MCCR the ability to perform accurate 90-degree and 180-degree turns, and also ensures that it is able to move in a straight line by performing corrections to maintain the same heading. Once the robot has turned to face the arena, it looks for pucks of a single color according to the construction plan. The camera is able to identify the location of the closest puck in its field. Since we have aligned the camera perfectly with the center of our robot, it is able to identify whether the puck is located to the left, to the right, or directly in front of it with a high degree of accuracy. Using the camera and the magnetometer, the MCCR is able to align itself with the puck and move towards it.
So basically, when the robot identifies a puck, it is going to try retrieve it using a gripper. For our project, we decided to buy the gripper instead of making it. This allowed us to save a lot of time in the workshop, and it was very effective as it was using only 1 servo instead of 2, which was easier for us to control it and manipulate it to open and close the gripper. The gripper is being controlled using a servo, and the servo is being manipulated using pulse width modulation, which is very accurate and precise. For the robot to know whether it's gripped a puck or not, we have been implementing micro switchers on both sides of the gripper, and the way it was working is that when any one of the switches is being pressed, it was breaking the search puck navigation loop and make the robot go back to the base. For the robot to go back to the base, we were using the ultrasonic sensors as well. The way the robot was going back to the base is by tracking down the same path it made to go and pick up the puck. But the only problem is that when it was going back to the base, it didn't know when to stop. So that's where we use ultrasonic sensors. And the way the ultrasonic sensors was working is that when the robot reaches a certain distance from the wall, it makes the robot stop. Returning back to the base, the ultrasonic sensor is going to detect when the robot is 13 centimeters away from the wall and make a 90 degrees turn, and then attempt to stack the puck.
All of the MCCR's decision-making ability comes from the software programmed onto the PSOC on its Glomerulia board. Coded in C on PSOC Creator, which provides software configuration for analog and digital hardware, some 500 plus lines of code were written, plus functional calls for all the individual robot devices in order for the robot to go about its tasks. Polling was the main method of communication with components, as it was felt that having the ultrasonics and camera trigger interrupts required too much complexity to implement in what was an essentially linear code. In the final competition, the MCCR probably exceeded the group's expectations going into the day. In the first round, the robot brought back 2 pucks to the white construction area, and in the final round it brought back 3 pucks, stacking 2 of them correctly according to the plan. The integration of the compass, ultrasonic, and especially the camera for both searching for pucks and returning to base was very effective, and by competition time it was fairly consistent at stacking pucks. The gripper and lift system was also effective, consistently reliable in terms of functionality. The group did, however, identify 4 areas of the robot that could be improved upon. Firstly, the MCCR probably needed one extra means of navigation to go with the compass, camera, and ultrasonic sensor, as its returning to base algorithm was fairly approximate. The addition of wheel encoders or perhaps a beacon at home base would have been handy. Secondly, the lift mechanism could have been quicker, consuming important competition time when in use. Thirdly, the MCCR could have used some form of colour sensor on the gripper for puck detection, as it occasionally detected the right puck from afar, but returned a closer puck that was in the way. Finally, due to the design of the chassis and the gripper size, the gripper dangled out the front of the robot and could quite easily be damaged if hit by other robots. Overall, the team was very happy with what was achieved and proud of the robot's performance.